Hello, it's Miss Aguilar once again, and this is the last part of the Unit 8 exam review. And we're going to pick up with this one. While on vacation, you shout or you visit a canyon, you shout at the far wall, and the sound returns after 6 seconds. The speed of sound that day is 340 meters per second. How far was it to the far side of the canyon? And then if the sound you made had a frequency of 600 hertz, what was its wavelength and what was its period? Okay, so let's take a look. First we're gonna solve for how far, so delta x. Whoops, let's get that pin one going. And we are going to use what we know. We know time and we know the velocity. Or do we know time? Time is the total time traveled, but we're just wanting to know how far to the side of the canyon. So if we draw a little picture here, this is you or whoever, and you shout or someone shouts, and that sound wave travels all the way from here to a canyon, and then, of course, it echoes back. It takes a total of 6 seconds. So the first time, there it's 3 seconds, and then back it's 3 seconds. We just want to know from here to here what was the distance. So we're going to use the time of 3 seconds. So we're solving for delta x. We know t, it's 3 seconds. Sorry, it's kind of sloppy. And we know velocity, it's 345 meters per second. So if we use our v is equal to delta x over t equation, we can rearrange that to delta x is equal to velocity times time. All right, so then we'll plug and chug. 345 meters per second multiplied by 3. Go away. Sorry. 3 seconds. Okay, let me put that in my calculator because I'm not all that, Okay, time. No, I'm sorry, delta x. 1,035 meters. That's how far it was from this point to that point. All right. Next part. Next part is asking to solve for the wavelength and the period if we have a frequency of 600 hertz. So now we can use our wave equation. Wavelength times frequency. And then we're going to set this up to solve for wavelength, and that's going to look like wavelength is equal to v over f. We know the velocity, it's 345 meters per second. And it told us here that the frequency was 600 hertz, and then I'm just going to divide the two, so 345 divided by 600, and you end up with a wavelength of 0.575 meters. We could just round that to 0.58 meters, and some of you will be like, well, why can't I just round it to 0.6? Well, because, you could just leave it at 0.575. Let's just leave it at 0.575. All right, we didn't really talk about significant figures all that much in this class, so we're not going to dwell too much on it. All right, what is its period? Well, how do we figure out what period is? Period is just the reciprocal of frequency. And what is that? T is equal to 1 over 600 hertz. See? Frequency. But this is a fraction. We do not do fractions in physics, so let's just turn it into a decimal. Simple. 1 over 600, and we end up with a number that looks like 0.001666667. Let's go with 0.0017. And the time? Seconds. But what does this mean? What does this mean? This means that it takes 0.0017 of a second for one cycle or one wavelength to occur, right? Yes. And it takes, 600 wavelengths will occur in 1 second. That's the frequency. And our wavelengths are 0.575 meters long. Nice. All right, this is it. This is the last part. The following pictures each depict a different wave phenomenon. Label each with the correct phenomenon. Phenomena. I just like saying that word. Why did I put phenomenon here and phenomena there? One's plural, huh? All you brainiacs, tell me which one is which. Okay, resonance. You should just be able to look at these pictures and not even see them as pictures, but see them as words. This is diffraction. This is, yes, very good, reflection. Why is it reflection? Oh, because these sound waves are traveling this way. This is kind of like that problem we just saw. You know, you shout something out, it hits the wall and it comes back. Well, it hits this object and that sound then reflects back to you. That is reflection. This is interference, but what type of interference is it? Well, we start off with a crest and a trough, or I'm sorry, a trough and a crest, and they cancel each other out. So this is destructive. Destructive interference. Interference. Could they make these words any longer? And then here we go. Well, if this is destructive, this has got to be constructive. Look at how big those amplitudes get when a crest and a crest meet and a trough meet. So this is constructive. Constructive. I'll tell you what, over the summer, I'm going to start reading the dictionary and learning how to spell my words better. I should have done that a long time ago. Interference. Do not depend on spell check too much, because then you'll end up like me. All right. This one's easy. We all know this. Doppler effect. And I think that this straw in the glass was a pretty easy one too. We've all been really exposed to this, and this is refraction. Yes? No? All right, guys. So that's it. That is the end. The end, the end, the end. But I just want to say a couple things. Study. Email me if you have a question, okay? Or if you have a concern or, you know, anything. And the last thing, the only equation that is going to be on your test is the wave equation. V equals wavelength times frequency. That's all it's going to be on there. So you guys should know everything else, okay? And I mean, this is all that you have to know. That's not a minus, that's a multiply. Okay? You should know the velocity is equal to delta x over t. You should know how to rearrange this equation. And if you do, you're going to be good. All right? Okay, guys. Well, I hope this is really helpful. And if it is, let me know, and then I'll keep making these videos. Have a fantastic day.